Subsequent to affirming start and accomplishing takeoff, early evaluations forewarned against gathering just fluffy photographs. Interceded with shuttle changes, NASA's Explorer 1, now more than 45 years old and 24 billion kilometers away from Earth, serves as a sign of science's lowliness in the vastness of space. In this investigation, we explore the mystery surrounding Explorer 1. Are we on the verge of losing association, signaling the mission's end? Is there a chance of extraterrestrial interference with the test? Join us on a journey through space to analyze odd signals and discover the true state of Explorer 1, the legendary adventurer. To understand the significance of Explorer 1's issues, we must first recognize its remarkable nature. Launched in 1977, the mission was expected to last only 5 years but has defied all expectations. Explorer 1 and its twin, Explorer 2, have exceeded expectations by relaying vital scientific data from the edges of our solar system for nearly 4 decades. Initially tasked with examining Jupiter and Saturn, they have succeeded beyond their original goals. In August 2012, Explorer 1 entered interstellar space after 35 years of mission, marking a milestone in space exploration. NASA confirmed this achievement in 2013. Explorer 2 provided close-up views of Uranus and Neptune. Explorer 1, the farthest human-made object from Earth, has transformed our understanding of space by revealing interactions between the solar wind and the interstellar medium, as well as the nature of the heliosphere. Explorer 1's journey has left a lasting legacy of space exploration. Scientists predict that the first contact with extraterrestrial life could occur by 2029, with messages reaching intelligent life forms as soon as 2022. This contact marks a crucial milestone in human history, igniting interest in the implications and highlighting Explorer 1's resilience. The device's longevity is essential as it can withstand harsh conditions like radiation, extreme temperatures, and the threat of micrometeoroids. Explorer 1's long-term journey showcases human engineering and the spirit of exploration. The spacecraft's longevity is attributed to its robust construction, designed to endure vast radiation, extreme heat and cold swings, and space debris. The mission's endurance can be credited to its reliable power source. Nuclear batteries known as radioisotope thermoelectric generators, RTGs. These generators use heat from plutonium decay to generate power. The RTGs have been the core of Explorer 1's power system for nearly 4 decades. Although their power production has decreased due to radioactive decay, they continue to power all scientific instruments on board. Explorer 1 is more than just a spaceship. It is an intelligent explorer equipped with scientific tools. Like a Swiss Army knife, Explorer 1 has a cosmic ray subsystem, CRS, a high-gain antenna, and an imaging science subsystem, including an infrared interferometer spectrometer, IRIS, low-energy charged particles, LECP, a magnetometer, MAG, optical calibration for the optical polarimeter subsystem, OPS, planetary radio astronomy, PRA, plasma science, PLS, and the plasma wave subsystem, PWS. These instruments perform significant functions. Explorer 1's close-up images have revealed details about giant planets and their moons, including Jupiter's cloud formations, wild winds, and storms. It discovered a volcano on Jupiter's moon Io. Saturn's rings were more than beautiful gems. They had unique twists and spokes. These instruments have studied cosmic rays, charged particles, magnetic fields, and plasma waves. Meanwhile, Explorer 1 carries a message from Earth to the unknown. The Golden Record is a unique attempt by humanity to connect with any extraterrestrial beings encountered on its infinite journey. The Golden Record is a 12-inch gold-plated copper disc with carefully selected sounds and visuals representing the diversity of life and culture on Earth. This disc has 116 pictures and a symphony of sounds that tell the story of our species and planet. It aims to bridge the gap between civilizations separated by space, featuring music and greetings in 55 languages from around the world, as well as natural sounds like thunder, birdsong, and whale calls. The committee, led by renowned astrophysicist Carl Sagan, carefully chose each element to represent a diverse range of cultures and If a sophisticated extraterrestrial society finds Explorer 1 and retrieves the Golden Record, it would be a historic event in interstellar communication. There are three possible outcomes. Extraterrestrial civilizations might use advanced technology to decipher the golden record, including visual and auditory information. Scientists anticipate that if extraterrestrial beings are capable of interstellar travel and communication, they may send a signal back to Earth by 2029. Alternatively, Explorer 1 could be studied as a historical relic without interference, respecting the principle of non-interference in the development of other civilizations, an idea explored in many science fiction stories. However, if there were ever an encounter with extraterrestrial beings, it would be a monumental and potentially world-changing event for humanity. Despite its long and faithful service, Explorer 1 has recently introduced an element of intrigue into its mission. It has begun sending puzzling data from the edges of interstellar space, putting NASA's engineers in a state of bewilderment. This anomaly originates from a critical onboard system known as the Attitude and Articulation Control System, AACS. This system is responsible for measuring, reporting, and adjusting the spacecraft's position in the vast expanse of space, ensuring that its antenna remains pointed at Earth for communication and data transmission. Yet, mysteriously, the AACS returns data that contradicts the spacecraft's actual movement and orientation. It seems as though Explorer 1 has become uncertain about its location in the cosmic void. NASA assesses the situation as both comforting and confusing. Despite incorrect data from the AACS, Explorer 1 continues to function correctly, receiving orders from mission control on Earth and gathering vital scientific data from its distant location. The spacecraft appears unaffected by the anomaly, and no onboard fault protection systems have been activated to put it in a protective safe mode. Interestingly, Explorer 1's transmission signal remains a strong beacon in the void. The high-gain antenna points to the right planet, yet the telemetry data produced by the AACS seems inconsistent or defies explanation. Suzanne Dodd, project manager for both Explorer 1 and Explorer 2, sheds light on this puzzling situation. The Explorer mission has faced unexpected challenges, including spacecraft aging beyond their designed lifespan, navigating interstellar space, and entering uncharted territory. Despite these challenges, the engineering team remains optimistic about finding a solution. In 2017, Explorer 1 faced a similar challenge when its primary thrusters began to wear out. To continue the mission, engineers had to switch to thrusters that had not been used in 37 years during the spacecraft's planetary missions. However, there is a new twist in the story. NASA's brilliant engineers have identified the problem with Explorer 1. It turns out the AACS was sending telemetry data to a computer that had failed long ago, corrupting the data. The project manager believed this was the culprit and took corrective action by repeatedly directing the AACS to send data to the correct computer. While the engineers are still uncertain about why the AACS malfunctioned, a faulty command from another onboard computer likely triggered this anomaly. If that is the case, it suggests that a fundamental issue on the spacecraft might exist elsewhere. The team remains committed to uncovering the root cause, even though they believe it does not significantly threaten explorers' overall safety. Nonetheless, they are eager to understand Explorer 1's inner workings better. Recognizing that time is running out for this brave Voyager is essential. This leads us to a pressing question. How long can NASA's Explorer continue its incredible journey before losing contact? Explorer 1 relies on a well-designed radio communication system that efficiently sends and receives radio waves through 3 Earth-based stations. When Explorer 1 communicates with Earth, it typically does so through Deep Space Network Channel 18 using radio frequencies of either 2.3 GHz or 8.4 GHz. Conversely, when we send messages to Explorer, we use a frequency of 2.1 GHz. This complex communication setup allows Explorer 1 to maintain a connection with our home planet even as it journeys into the vast unknown. However, the distance Explorer 1 has traveled means that direct communication with Earth has become increasingly challenging. To overcome this, the spacecraft is equipped with a digital tape recorder, DTR, capable of storing approximately 67 megabytes of data. This recorded data can then be transmitted back to Earth later when conditions for communication are better. As of 2023, it takes more than 22 hours for signals from Explorer 1 to reach Earth, which is a stark contrast to the approximately 15 minutes it takes for the Mars rovers to transmit data back to us. Another critical factor to consider is the weakening of Explorer 1's signal as it traverses vast cosmic distances. The spacecraft begins data transmission to Earth using a 20-watt signal. However, over its long journey through space, the signal gradually weakens. By the time it reaches Earth, it has become incredibly faint. Nevertheless, the strength of the signal is not the primary concern when communicating with objects at such enormous distances. The crucial factor is having a sensitive receiver capable of detecting these weak signals. To address this challenge, NASA relies on the Deep Space Network, DSN, a network of 3 antenna complexes strategically located around the Earth. Each complex boasts a large 70-meter antenna and multiple 34-meter antennas. These facilities can combine their capabilities to detect signals that are millions of times weaker than a standard FM radio transmission. The DSN allocates several hours daily to monitor these faint signals from Explorer 1 and has consistently demonstrated its sensitivity over the past 5 decades. Our methods for detecting faint signals have advanced significantly, making us confident in our ability to continue hearing from Explorer 1 for years. It is worth noting that our communication setup has been a primary factor in maintaining contact with Explorer 1. The DSN has played a pivotal role in this achievement. However, despite its remarkable capabilities, there will inevitably come a day when we can no longer communicate with Explorer 1. At that point, the signal will be too weak, even for our most advanced receivers. Explorer 1's ability to send data will continue until it depletes its limited power. NASA estimates that this critical moment will occur around 2025, which will be the effective end of Explorer 1's mission, although the spacecraft will continue its journey silently. It will then drift through space, carrying its message of human curiosity and exploration. However, the team remains optimistic about finding a solution and is determined to address this issue. Despite the spacecraft's age, they are not ready to give up and are actively exploring potential remedies. As Explorer 1 continues its journey, we honor its accomplishments and await the intriguing data it will provide from the far reaches of interstellar space. The mission of the 2 explorers has profoundly impacted our understanding of the cosmos, and they serve as a testament to human ingenuity and the enduring spirit of exploration. They have forever changed our understanding of the universe. As we celebrate Explorer 1's achievements, we also look ahead to the next generation of interstellar explorers who will follow in its footsteps, advancing our knowledge and pushing the boundaries of what is possible in space exploration.